Hi there, Mrs. Thompson here. Today we're going to look at compounds with polyatomic ions. Here is that list of polyatomic ions that you're given. There were a few that you had to memorize. We're going to start using them now in compounds. There is a smaller list, and that is in your textbook on page 224. Okay, so we need to remember what a polyatomic ion is, and that is a group of atoms that when combined together, they carry a charge. So in these two examples here, I have ammonium, which is one nitrogen in the middle, 4 hydrogens. Those are all bonded together, and then they all together put out a +1 charge. This one is phosphate. Okay. Phosphorus is in the middle, 4 oxygens on the outside, and altogether they have a 3- charge. Now the phosphate is an example of an oxyanion. An oxyanion, remember, is any polyatomic ion that has oxygen in it. When working with polyatomic ions, you never want to change any of the subscripts that belong to the polyatomic ion. So we'd never change this 4 here or this 4 here. We'd simply just use the charge to figure out how many of them we need. And if we need more than one polyatomic ion, what we're going to do with that is we're going to place them in parentheses so that we can tell the structure that that's a polyatomic ion and we need several of them. So let's do a first example, magnesium and nitrate. Magnesium is in group 2A, so it's a 2+ charge. And then nitrate's one of the polys you have to have memorized. It's NO3 with a 1- charge. Okay. So we're still going to look just at the charge. I'm going to ignore the subscripts completely as if that were just part of like an atomic symbol. All right, so if we have a 2+ and a 1-, we're going to need another nitrate. Notice I'm not looking at this. I'm just simply looking at the charge in the upper right-hand corner. So I'm going to bring one more nitrate over. And so now I have a total of 2+ on the left and 2- on the right. And then I'm going to figure out the formula for them. I will need 1 magnesium and 2 nitrates. This should look funny to you. It looks like we have 32 oxygens. That's not true. So what we need to do, that's wrong, is we need to fix that and put parentheses around the nitrate. And so remember when we were talking about how to figure out the number of atoms, that 2 would distribute in, but we don't do that. We say that this is 1 magnesium combining with 2 nitrates, 2 polyatomic ions, and it gives us an idea of what that structure would look like. Next one is calcium and phosphate. Calcium is a metal in group 2A, it's a 2+. Phosphate is PO4 with a 3- charge. Here we have a 2+ and a 3-. Remember that we can figure out what both of those will go into. They'll both go into 6, so we'll need 3 calciums and 2 phosphates so that we have an overall charge of 6 on both sides. And so that's 3 calciums and 2 phosphates. Notice the 2 is outside of the phosphate, and the phosphate is in parentheses. Okay, next example is copper 2 hydroxide. Remember that copper 2 just means that the copper is a 2+ charge since copper is a transition metal. Hydroxide is OH-. We'll need another OH- so that the 2 negatives cancel out the 2 positives. Bring that together, and it's CuOH2. Now students often can't see that this looks funny because there isn't 2 numbers next to each other. So just be careful with your hydroxides. You do need to make sure you put parentheses around them. They are polyatomic. You have 2 capital letters here, 2 different elements. Okay, next we're going to go in the opposite direction. We're going to take compounds that are already made and name them. So the rules. Just same rules before, name the cation first. We'll want to make sure that we're checking for any multi-charge transition metals so that we can put those charges in Roman numerals. We'll name the anion second. Just a little note, remember that the endings for monatomic ions, those are the nonmetals, those change to IDE, but if we have a polyatomic ion, we don't change the name ending at all. And just to keep track, it's easier if you draw a line after a metal or ammonium now that we're working with polyatomic ions. So you can see where the cation ends and where the anion begins. All right, so let's try these examples. Okay, first one, calcium chloride. Oh, I said the name. We'll draw a line after calcium. Name the cation, it's calcium. And then chlorine, since it's just a monatomic ion, that changes to IDE. So this is calcium chloride. Next one, draw a line after sodium. Sodium is the metal, and then the rest is the polyatomic ion. I can tell because I have more than one capital letter. And so here's where you go to your polyatomic ion sheet if you don't have them memorized, and you look up what is C2H3O2. Well, that is acetate. Everything after that line is the polyatomic ion. That's why I suggest you draw the line. So this is just sodium acetate. Okay, the next one. Here we have it starting with nitrogen, and nitrogen's not a metal, but what we do have for cation is we have ammonium. Your ionic compounds are either going to start with a metal or ammonium. So we'll draw a line after ammonium. That means that everything else after the ammonium is your polyatomic ion. So I'm going to look up NO3 on the list. That is nitrate. So this is ammonium nitrate. Next one, we have Cu, which is a metal. That's copper. And then we'll look up SO4. That's sulfate. So we have copper sulfate. We do need to make sure that we remember to check for multi-charges. Calcium is a group 2A. Sodium is a group 1A. Ammonium isn't a metal at all, but copper is a transition metal. It can be copper 1 or copper 2. So we need to figure out which copper do I have. Well, I'm going to work backwards. I have copper, 1 sulfate. If sulfate is a 2 minus, in order for copper to cancel out that 2 minus charge, copper should have been a 2 plus. So I'm going to put Roman numerals 2 next to the copper. All right. When we're working with oxyanions, just a couple things to remember. An oxyanion name changes as the number of oxygen atoms change, but their charges stay the same. So I had you memorize 8. A couple of ides like cyanide and what else? Hydroxide and ammonium. But most of the ones that you were supposed to memorize were the 8 ions. That's because you can change any 8 into ites and hypoites and per-ites. So we'll see how to do that. So you need to draw this table. Let's see if there's a good spot for me. Okay, so when we're talking about this table, we'll always start with a normal form, and this is the most common form for that ion is the 8 form. So nitrate, sulfate, phosphate, carbonate, and so on. So our example here is chlorate. Chlorate is ClO3 with a -1 charge. Unfortunately, the 8s don't tell you how many oxygens there are in the polyatomic ion. They simply tell you that that is the most common form for that polyatomic. Okay, so if we have chlorate, ClO3, 1-, we're going to change that into the per-8 form. Now, according to this table, per-8, we're adding a prefix to it, is 1 more oxygen than the normal form. So if chlorate is ClO3, then perchlorate is going to be ClO4 with a 1- charge. Notice that the charge didn't change. The only thing that changed is the number of oxygen atoms. Okay, let's try the next one. What if we change it to the ite form? So from normal to ite, that's 1 less oxygen than the 8. So chlorite would be 1 less oxygen than ClO3. That would be ClO2, and the charge doesn't change. Okay, then we go to the hypoite form. So an example of that would be hypochlorite. So we would take 2 less than the normal, or 1 less than the ite form. So this would just be ClO with a 1- charge. So now you should be able to take things like bromate and iodate, which were other polys that you had to memorize, and change them into perbromate and hypobromite and periodite and so on. Okay, next we're going to try some examples. So we're going to take nitrite and figure out what the formula is. Well, ite, where is that coming from? It doesn't have a prefix. It's not hypoite, it's just ite. So if we are starting with 8 each time, we'll notice that it goes from 8 to ite. It goes from normal to 1 less than normal. So we need to figure out what normal is. Nitrate is NO3 with a 1 minus charge. We're going to take 1 less oxygen than NO3, keeping the charge, and that would be NO2 with a 1 minus charge. That's just 1 less oxygen. So NO2 would be my answer for nitrite. Let's try another. We have hypophosphite. Okay, and let's see, where's hypophosphite? So that would be, hypoite. If we're starting from 8, that would be 1, 2 less than the 8 form. So let's figure out what the 8 form is. It's PO4 with a 3 minus charge. So that means we're going to remove 2 oxygens to get to hypoite. So 1 oxygen would be PO3, 2 oxygens would be PO2. And so hypophosphite would look like this. Let's try per iodate. So let's see this chart. Up here we have to get to 8 to per 8 would be to go up from the normal. And so we'd need 1 more oxygen than iodate. So let's look up iodate. It's IO3 with a 1 minus charge. If we add another oxygen to that, it would be IO4. All right, let's try some working the other way. What if we have the formula and we need to name it? So BO2 with a 3 minus charge. Well, let's figure out what is BO2. Well, that's got to be borate, something like that. So let's look that up. Okay, here's borate. Borate is BO3. So if it's BO3, that means originally it was BO3, that it went down 1. It lost 1 oxygen. So it's not borate, but it's borite. Okay, next one we have SO2. So that means we had something related to arsenate. So let's look up arsenate. It's ASO4 with a 3 minus. Well, if it was originally O4, that was the 8 form, it had to go down 2 times to lose 2 oxygens. So that would be hypoite. So that would be hypoarsenite. Okay, and the last one, we have something related to selenate. So let's look that up. That's SeO4 with a 2 minus charge. So if that's the 8, that's only 1 less oxygen. So that must be selenite. Okay, so you should now be able to take any polyatomic ion that's an 8 form and change it. All right, so here's a trick for memorizing oxyanions. You can use this trick or just simply try to memorize them, but I'm going to give this trick to you anyways. And so it works like this. This section right here of the periodic table. So if you can find this section on the periodic table and remember where it's at, this will help you. It goes in this pattern: 3, 4, 3. 3, 4, 3. Okay. So let's see what I mean by that. So here's the periodic table just enlarged here. You might want to copy this down or write it in your periodic table. But here, these top 3 all work like this. They all have 3 oxygens. So BO3, CO3, and NO3. So that's borate, carbonate, and nitrate. I haven't added the charges yet. I'll do that later. So there's the top 3. Then we have the middle 4. Those all have 4 oxygens. So you have phosphate, arsenate, sulfate, and selenate. Then we have the next 3. So 3, 4, and then 3. So those all have 3 oxygens in them. chlorate, bromate, and iodate. Okay, now it's time for charges. Simply go across the top, it's 3, 2, 1. And then across the next row, it's 3, 2, 1. And across the next, 3, 2, 1. And then the bottom is simply with the other ones, it's just a 1. There isn't any 3, 2, 1s, it's just 1. Okay, so hopefully that helps you to memorize the polyatomic ions, at least some of the lists that you have to have memorized. That's 1, 2, 3, 4, 5, 6, 7, 8. 8 of the ones you have to have memorized. Okay, hope that is helpful, and we'll see you soon.